In this class we will solve some more sums based on EMF connected in series and parallel. First take down this question. A battery of EMF E and internal resistance R gives a current of 0.5 amps with an external resistor of 12 ohm. Resistor of 12 ohm. And a current of 0.25 amps with an external resistor of 25 ohm. External resistor of 0.25 amp with an external resistor of 25 ohm. Calculate internal resistance of the cell. Internal resistor of the cell, EMF of the cell. A battery of EMF E and internal resistance R gives a current of 0.5 amps with an external resistor of 12 ohm and a current of 0.25 amps with an external resistor of 25 ohm. Calculate internal resistance of the cell, EMF of the cell. Now here given we have two cases, that is the cell is available and its internal resistance is R. When the cell is connected to an external resistor of 12 ohm, the current is 0.5 amps. When it is connected to external resistor of 25 ohm, the current is 0.25 amps. With these two cases given, we need to find out what is E and R. Now we'll try to solve this. So the first case is the cell connected to the cell with internal resistance R, and it is connected to a battery of the battery which is connected to an external resistor of 12 ohm, and the current in the circuit is 0.5 amps. This is the first case. And in the second case, we have external resistor as 25 ohm and the same cell. Now the current in the circuit is 0.25 amps. 0.25 amps. We know the total current in the circuit is total EMF divided by total resistance. We will apply these two equation. If this equation for both the circuits, the total current I is equal to E divided by R plus R. So in the first case, I becomes equal to, I is 0.5 amps, 0.5 is equal to E divided by R plus 12, or R plus 12 equal to 2E. One by 0.5, which is 2. Let us take this as equation 1. Similarly, apply this equation to the second circuit. The current is 0.25, which is equal to E divided by R plus 25. Or we can write R plus 25 equal to E divided by 0.25, or 1 by 0.25 is 4. So I can write this equation as R plus 25 is equal to 4E. Now we have two equations, equations 1 and 2, and two unknowns. So let us solve for R and E. So from equation 1 I can write E is equal to, from this equation 1, I can write E is equal to R plus 12 divided by 2, or it is equal to R by 2 plus 6. Now equal to R by 2 plus 6, substitute this value of E in this equation, equation number 2. So I can write here, substitute the value of E in equation 2. Equation 2. So we get R plus 25 equal to 4 into R by 2 plus 6. This is equal to 2R plus 24. Now solve this equation for R. 2R minus R is equal to 25 minus 24, or R equal to 1 ohm. R equal to 1 ohm. Substitute this value of R in equation E. So we get the value of EMF. E is equal to R by 2 plus 6. This will give you the value of E, half plus 6, which is equal to 6.5 volts. So E is equal to 6.5 volt. So we found the answer for both of our questions. So question number A is answer. That is A, the EMF of the cell. First one is internal resistance equal to 1 ohm. And question number B, EMF of the cell. equal to 6.5 volts. The internal resistance is 1 ohm and the EMF of the cell is 6.5 volt.